This video is designed to help you understand how to determine the tangent on a position versus time graph. We discussed in class that if you look at a position versus time graph of an object with accelerated motion, that you can estimate what the velocity is at any given point in time by drawing a tangent line. As you can see on the graph here, we have 4 different points with 4 different tangent lines drawn at those points. Remember, a tangent line is a straight line that hits a curve at only one point. And we can get a lot of different information from this particular example of these tangents on this graph. You can see at point A, we've got a positive slope, so that means that the velocity is positive at that point. At point B, there is no slope, so that means the velocity is 0. At point C, we can tell that the velocity is negative. And at point D, we can tell again that the velocity is positive again. Not quite as positive as A. So you can actually do some comparisons. The object at point A is going faster than the object at point D, even though it's at a different position. What we can also do, if we find the instantaneous velocities at different points along a curve, is we can actually calculate the acceleration. As you can see in the bottom corner, the formula for acceleration is the change in velocity over the change in time. So if we actually put numbers to these slopes, we can pick any two velocities, let's say velocity 1 and velocity 2, and you can find the difference between those two velocities. Therefore, you can find the acceleration using a position versus time graph. Let's take a look at a couple other examples. If we look at this position versus time graph, you can tell that the motion of this object is constant. Well, what that means is if I were to draw a tangent line at any point along the way, say here and then here, well, the two slopes are the same. Therefore, the acceleration would be 0. That's another way to explain from a position versus time graph that the object is not accelerating. However, this unit we are working with objects that are accelerating. So let's take a more detailed look at how to specifically find tangents. Let's say that you were asked to find the instantaneous velocity at point 3, at time 3. So I'm going to highlight that. So how do we find the instantaneous velocity there? Now you could try to just hand draw a line, but there's actually some steps that you can do so that you ensure that you are getting the correct slope of that tangent line. So what you do is you pick 2 points that are equidistant from time 3. So I could pick time 2 and time 4, or I could pick time 1 and time 5. Either set of points that I pick, those are equidistant from each other. Time 2 is 1 second away from time 3, as well as time 4. So what I do is I find those points on the line, and I make a straight line. So let's pick time 1 and time 3. I'm sorry, time 1 and time 5. If I draw a straight line between those 2 points, time 1 and time 5, I get a nice slope. Then what I do is I transfer that line using a ruler or a pencil and drag it down to where it meets time 3. Now I have the instantaneous velocity at time 3. Another way of thinking about that is that the average velocity between time 1 and time 5 is the same as the instantaneous velocity at the midpoint time between those two. So the average velocity between time 1 and time 5 is the same as the instantaneous velocity at time 3. If we had a better graph, we could actually find 2 points along this line to find the actual slope of this line. I could have also done this between time 2 and time 4 just as easily. So if I find the average velocity between time 2 and time 4, so pick those 2 points, draw a straight line, and then we transfer that down until where it meets time 3, you'll notice that that's the tangent line. Again, the average velocity between time 2 and time 4 is the same as the instantaneous velocity at the midpoint. In class, you'll be given some examples and some problems where you will actually put some numbers to this. But to summarize what we have just talked about today, On a position versus time graph, you can find the instantaneous velocity at any point along the line by finding the tangent. And if we find the average velocity between 2 points, that's going to be the same as the instantaneous velocity at the midpoint time. And if we know on a position versus time graph what 2 different velocities are, then we can calculate the acceleration by plugging into the formula delta v over delta t, the change in velocity divided by the change in time. This video is just focused on finding tangents on a position versus time graph of accelerated motion, but what I want you to write down is your answer to the question at the bottom. What do you think the tangent of a velocity time graph represents? So write that down, bring it to class, come with any questions so that we can start doing practice problems together.